Welcome to the stress session, the stress test session. Stress tests with Gatling. My name is Niko Köbler. I am a freelance consultant from Germany, and I'm doing all sorts of web development, architecting, software, whatever. And that's me on Twitter. So as every speaker, I appreciate every mention on Twitter. So if you don't mind, yeah, I will appreciate that. And yeah, I think all of you know such a situation. Stress in your projects. Who of you is actually doing stress tests in your projects? 1, 2, 3, 4, 5. Okay, about 10 persons. Who of you is doing this regularly? Well, 4, 5 people. In the build process or regularly manual? Build process, great. Okay, the other ones, no stress tests at all. And how do you do this? Asking your users to click around like wild in your application for about half an hour. Is half an hour enough? Perhaps stress test has to be some hours, some days. You can't force your users, your employees to test a few days without pausing to test your application to find bottlenecks. I think in the past, most of you heard about JMeter, a very old tool. No, not an old tool, it's a major tool. JMeter is based on this pretty language XML. It's very trending at the moment, and it actually consists of tons of XML configuration for configuring your stress tests, your requests, and whatever. And because it's bound to XML, you are bound to the possibilities of XML to execute your tests. I think yesterday or the day before yesterday, I read something on Twitter that now JMeter includes Groovy to be able to use scripting. But then how is Groovy stored within the XML? And I don't know if I want to use this or if I want to maintain this. And I think we can do it better today than using this old XML stuff. And also, if you're configuring your last test, your stress test with multiple developers per time, in JMeter you only have one big XML file, and so we will run into merging conflicts when committing them in the versioning system. And also JMeter has a very temporary look and feel. And you have to click through all these things, and yeah, also the reports are looking very nice for today. And I think it's time for something new. And there's a new kid in town, and it's actually not really new. I think they started 4 or 5 years ago with developing of Gatling. And yeah, Gatling wants to be the new stress testing tool, the successor of JMeter, the tool which does multiple things better than JMeter. And Gatling is based on the Scala, Akka and Netty stack. And so because it's based on the Netty IO framework, you don't have to, you are not bound on executing threads at one parallel time. So you have in Netty this event loop, and you can initiate multiple very high load of parallel requests and testing your application. And yeah, did I say Scala? I'm not a Scala boy. I don't know Scala at all. Perhaps 2 or 3 commands from Scala. I'm a Java and JavaScript guy, so I'm totally new to Scala. But you don't have to learn Scala to use Gatling, because Gatling just uses Scala for building up a DSL, and you just have to use this DSL. You just have to have some small programming experience, of course. You have this, otherwise you weren't here at this conference. And you can use the DSL in your IDE. You have auto-completion and type ahead and such things. How to get started? You can download simply a complete bundle of Gatling and use this. This is what I will show you in a few seconds. And you can use the dependencies in Maven or in the Scala build tool for integrating the tests in your build. So you have a recorder in Gatling for recording the scenarios you want to test. And let's start with this recording session. I simply have to start the recorder. Okay. The recorder itself works as a proxy, and your browser has to point to this proxy, and the recorder will forward your requests to the server. The recorder, you can configure some things. You can give a package, but just want to have a Voxxed simulation. Voxxed simulation, and just ignore some static resources in the web application we are using, because we are not interested in the behavior of static resources. We want to test our application, and just hit start. Now the recorder, the proxy, is waiting for requests we are executing, and we're just giving some tags. I will show you them later, what the tags are. And I will start my Firefox browser, and this is a website provided by Gatling for testing purposes, just a computer database. And so we can search for a computer, for a MacBook, and we can open the MacBook, have a look at it. Everything's great. Turning back to the home page, and if we have now a look to the recorder, we see all these requests we have done in the recorder. This was the home page. Then there was a pause from about 183 milliseconds. So the recorder is also recording the breaks we're doing. So the recorder records a real scenario, a real situation, like so that you can simulate yourself when running the script. This is the search for the MacBook. This is the GET request for opening the dedicated computer, and so on. And now we want to have some simple browsing. We add another tag, go back to our application, and then we say we're just browsing from page to page. There's nothing spectacular in there. And we have these 5 pages recorded. And for the sake of completion, we're doing now something, an edit task, and we're adding a new computer. This is our Voxxed box, and it's introduced, of course, today. It's not discontinued, and it's by, don't think that Voxxed is in this, but yeah, it's, of course, by Apple. And we can create this computer, and also our post request. It's been recorded by the recorder. That's our complete scenario. We want to stress test later on, so we can stop and save at this point. And we can close the recorder. So when we have a look in what was recorded as a file, a Scala source file, Voxxed simulation. That was the name which I gave at the beginning, and this is the Scala code which is transformed out of our recording. So it's pretty readable. First, you have some protocol settings about our browser we used. We had a blacklist of all the static resources. We had a base URL in which we are executing the tests, accept headers, encodings, user agent, whatever, all the stuff we need. And then the simulation starts, the Voxxed simulation, and here's our tag. We gave into the recorder the search tag. There are some requests to the root, the search request, the dedicated computer, and the browse tag. We started browsing on page 1, page 2, page 3, page 4, page 5. And at the end, we have our edit task. And this was our post request. We filled in a form, some values, and posted it to the application. And then we set up all things together and say we want to inject at once one user. That's the default setting. At once one user inject into the scenario and execute it. So if we now start the whole thing, no, was Windows, that's right. If we now start Gatling, Gatling will compile all the sources in the, oh, great. There's no simulation script.
You have deleted by mistake a line, I think.
No, that was not by mistake.
It's line 45, but
45?
the red thing, I don't know why it generated that line.
Okay, so I will just delete this.
Yeah, probably yes.
Okay, looks better. Thanks. So now Gatling is compiling all the scripts. And there are some more scripts in the directory, just the demo scripts which came with Gatling when you download it. And we have our Voxxed simulation at number 0. And we choose number 0. We can select some descriptions and other things. Just skip this for now. And now the simulation is started, and Voxxed is replaying the whole scenario which we have recorded with the original pause times. So this takes quite some seconds, as I did always pause and talk to you. And every 5 seconds we get some response from Gatling, which tells us which requests are executed. So this will run a while. And yeah, I've talked pretty much, I think. And in the end, if Gatling has finished the test, it produces a report which you can open in a browser and have a look at which response times the requests were executed, and some other figures. That's not very interesting if we ran one scenario with only one user. This became interesting later on if we have more than one user. I will think I just want to skip this time. Having this script is not so very useful at the moment, but we can start tweaking this whole thing. As you remember, we have a search, a browse, and an edit task. And so we can, because we have a programming language at hand, Scala, we can start doing some objects. We have a search object, and we have a browse object, and we want to create an edit object and just say our search, and we take all this from our search, just cut and paste it into the object, and the same thing for browse. Take this one, browse, including the break, and of course the edit function. So we can delete all this, and this is a value object. Looks good. And now we have to set up our scenario and execute our search, our browse, and our edit tasks. And this is a bit more, better overview of all the things. And I just will cut down the pause times to just 1 second, so the test will run much more faster. You shouldn't do this for your production tests, of course. And yeah, if you know, start again the Gatling client and recompile the source, and we can run the Voxxed simulation. Now it's starting, and yeah, you see also after 5 seconds there are more tasks executed. It's finished with 12 requests, and we take the file, the path for the report, and just open it in the browser. And this is what the standard Gatling reports is looking. You have an overview of all the tasks, the requests, request 1, request 3, redirect 1. Overview of all the response times of the various requests, the global information, requests per second, which would be possible with this performance. I think the network in here is too good to have some failed tests, unfortunately. And yeah, active users along this simulation, we have only one user at this time, so there's nothing spectacular. Response time distribution, this is very nice. How much of the responses were fast, how much were not that fast, and some other figures. Okay, let's get back to the code. Only one user is way too less. So let's start having some regular users and perhaps some admins. We have users, and they have the scenario is called users, and they're executing, just copying this one, and we'll rename this one as admins. This is admins, and the users won't edit the database, just the admins will edit it. So we just configure the admins with the edit task, and the regular users don't have the edit task. And now we will set up our no overdue. Oh. The users, I will inject 10 users over 10 seconds. So all what you see is the Gatling DSL based on Scala code. And of course we have the admins. We also inject only 2 users because admins are normally less than regular users. Also over 10 seconds. And there's a praise. And of course we have to use the protocol, our HTTP protocol, HTTP protocol from the beginning. Yes, that's great. And yeah, now we rerun again the Gatling client, and we will see that there are more requests at the same time and in total. There are already 76 requests after 10 seconds. And now it's running a bit longer because we have more requests. In total, we have 113 requests. And if we now open the report, we have another distribution of all the things. Theoretically, there were 6,333 requests per second possible, and this is our active users during our test. There was a ramp up of all the users. The blue line is the admin users, the green line are the regular users, ramping up over 10 seconds, and then they are going down as they are finished. The response time distribution, most of the responses we see were pretty fast. There were a small percentage of very long requests over 1 second and such things. And I'm still not satisfied with this code. That's not the best thing. So we have this browse task. We have a page 1, we have a page 2, page 3, and 4, which I deleted, which was recorded in the wrong way. But we have the same requests ever and ever again. So we can shorten this. I have the possibility to say repeat this task about 5 times and store the value of our repeat loop in a variable called I, and then I will was correct. Okay, I'll just delete this code and say just use the variable I. And because this is the Gatling expression language, not the Scala replacement, we have to delete this S before the string when our IDE inserts it automatically. And we can also tell here this is our repeat. I'll just tell browse step I. And now this browse step will be repeated 5 times for every execution. So we can have less code for the same execution. Again, we will start the Gatling tool. Startup is pretty long because the Scala build tool is not the fast one. And then we're starting the simulation. And waiting just to finish. And we can already see in this overview, we have the browse steps 0 to 4. And then if we open again the report, there are here are our browse requests, browse step 0, browse step 1, browse step 2, and so on. Also in the overview, we have our browse steps, and in a detailed view of all the single requests, we can also show have a look to the single requests. That's quite good so far, but now all the users are executing the same requests with the same data. That's not what we want to achieve in our production load tests. So we can inject data from various sources. For my example, I have a comma-separated value file, but also possible are CSV, tabular separated, semicolon separated, JDBC source, Redis source, and I think also some queuing is possible. Let's have a look how we can include these data in our tests. We just take our search test for this, and no value. Gatling has the concept of so-called feeders. We can feed the test with data, and it's just called CSV for CSV file, and I just have to provide the name. In this case, I don't have to provide a path because the Gatling tool is pre-configured using this data directory for the source directory for data files. And then I can use the data from this file. And the default way using it is in a sequential way, use the values one by another until the file is finished. And if your tests are not finished, but the data is finished, there will be an exception. And you can choose some other option. You can say use it in a circular way, so start at the beginning if you reach the end, or use it in a random way. The queue is the default, and we want to use it in a random way. Just choose some random values, and we have to inject at a certain point this in our execution, and that's all we have to do. Feed with the feeder, and every time the test execution comes to this line, one random value is taken from the file and be injected in our test execution. And then we can say get our computers with our search criterion. So, and where did I specify the search criterion? It's just the header line of the CSV file. So Gatling uses the first line in the CSV to use for the variable names. And so we can have a look to the search criterion, and then we can also no, at this point we can do also a check, and with the CSS selector of an anchor which we found in the response, and this anchor should contain our search computer name, which we specified. This is wrong, so this looks good. Okay, and we want to store from this selector, from the CSS selector, our anchor, the href value, and save this as the variable computer URL. And this should be okay. Yes, syntax is great. And so we're now storing the link, the value which is placed in the href attribute from our link, which has the computer name in it. The computer name is also coming from the CSV file. And store this value in the variable computer URL. And afterwards, we can just use this to request our computer URL. And no, this one. And also we'll do that check that the status is 200, so that we can get a reasonable response from the server. So let's test it. Should run. Simulation is starting. Looks good so far. Unfortunately, I gave the tasks no new names, so can open the new report. And unfortunately, we won't see anything because it's only called request 1 and request 2. Because perhaps we should just add the search criterion again, run it again, and so the computer URL. Then we will see it also in the reports. The compile time is very slow, especially when you stand on the stage and wait for the compiler to finish. So we can see the request MacBook and the request EEE and some requests for computers 525, and the other value has been executed. And once again, we take the test, open it. Oh. Looks better. We have also our MacBook and EEE requests and the single requests to our computers. Active users looks pretty similar to the beginning. The response time distribution just depends on the network quality, of course. And yeah, this is how you can adjust the tests for your needs, to inject random data, to inject circular data, whatever. The data can come directly from a database, from a Redis store, so you don't have to provide all the times a CSV file. You have loops in it, and you have pretty much more to configure in your tests. And there's some code in my slides just for backup. Yeah, you have advanced users, you have a ramp-up users, which we have used in our case, or you have a constant users per second. So you can simulate 1,000 users during 10 seconds in this case. And there's a cheat sheet of Gatling, which is a pretty cool cheat sheet showing all the options you have. And these are the injection steps, for example. You have advanced users, ramp users. You can say nothing for a random time, constant users per second, split users, can specify heaviside users, whatever. And so you can configure your tests pretty good to your real-life needs. And one thing I have not in my tests here, but only on the slides, you have global assertions, but I can use to include it in the tests. Global assertions for specifying global conditions if the test was passed in the whole, not only the single requests. So the response time should be less than 50 milliseconds. If you have a look at the actual response time distribution, let's say 100. There are still few over 100 milliseconds, and the test is overall successful if I have successful requests greater than 95%. And one brace, okay. So let's start again, one more time. Just select the test. So it should be finished. And we take the URL, and we also see at the console there's a global max of response time is less than 100 seconds. This was false because there were requests which are higher than 100 milliseconds, and the percentage of successful requests is greater than 95%. This is true because there were at maximum 5% of the requests which are faster than 100 milliseconds. So we have the global assertion less than 100. This is knocked out, and the other test is okay. And this is our response time distribution. So we see that just from this point on to the right are less than 5% of the requests, and so the whole test has passed. Okay. So the reports I showed you already. Another great thing of Gatling is the option of real-time monitoring. So if you're running your tests over several hours, you don't want to wait these days to finish the test and have a look into the reports. And so this is Gatling supports the Graphite protocol. And with the Graphite protocol, for example, you can store the values Gatling is gathering at the time in a time series data store like InfluxDB. InfluxDB is a special data store which focuses on storing time series data. If you're interested, have a look at the website. And Grafana is a special visualizing tool like Kibana for search data. Grafana is a visualizing tool for time series data, and it's available at grafana.org. The dashboard looks pretty colorful, and so you can pull the results which Gatling is gathering while executing the tests into InfluxDB and run reports with Grafana on InfluxDB and have the results right quite real time, not really real time, near real time, and but much more faster than the tests are finished at all. And this is also a way which can be used to do distributed testing. Gatling does not provide an explicit option for distributed testing, but if you think of using build slaves, have several Jenkins instances, or building and running fat jars, which Gatling is currently developing for building fat jars. So you can distribute them over several nodes, starting them and do the reporting into Influx database and do the reporting with Grafana. So you can achieve very good distributed testing. Yeah, last but not least, Gatling is very trending. They achieved last year the 200,000 download benchmark, and since I'm using Gatling and I'm telling other people about Gatling, they are all pretty fast convinced about this tool, throwing away JMeter. You don't necessarily have to be a Java developer or a Scala developer. Also in a PHP project in the last year, the developers were pretty excited about Gatling, how to use it, how simple it is to use, how to set up all the test scenarios. Yeah, that's it. And if you have any questions, I will be happy to try to answer it. Yeah.
Quick question. Or you would compare Gatling with LoadRunner?
How I would compare Gatling with LoadRunner? I must confess, I don't know LoadRunner.
Looks similar.
Okay. Sorry. Other questions? Yeah.
Yes, there is some cloud service that support Gatling. Cloud service support Gatling to testing with
Support from Gatling, from the company Gatling. Oh.
some cloud service that allows to run Gatling, load Gatling, the cloud.
A cloud service running Gatling. No, I don't know any about them. I don't know if this is really useful for companies providing a Gatling a cloud service, because stress testing tool is also a possibility to run denial of service attacks against websites. And if I provide a cloud service for running denial of service attacks, don't know if this is the best thing for my business model. Okay. No more questions? Then I will say thank you for coming, listening to my talk, and happy testing.